Hi everyone, in this video I'll be explaining how an AC to DC power supply works using a full wave rectifier. My team members are Ahmad Mohammed, Yap Jun Sian and me, Danish Zikrullah. Let us start with the schematics of the full wave rectifier. It consists of an alternating circuit source, 4 diodes, a filter capacitor, a Zener diode following with a load resistor to prevent the Zener diode from having a Zener breakdown. So, in a full wave bridge rectifier, the current flows during both the positive and negative half cycles of the alternating current. During the positive half of the cycle, the current flows through the diode of D1 and D2 and through the load. During the negative half, it will go to the D3 and D4 and still going to the load in the same direction. This way, both halves of the alternating current waveform is used, producing a pulsating DC output. So, what is the main function of the rectifier, you ask? The main function of the rectifier is to convert the alternating current into a direct current. A full wave rectifier is more efficient than a half wave rectifier because it uses both halves of the input signal. That's why we choose the full wave rectifier. After the rectification of the alternating current, we get a pulsating direct current. To smooth this out, we use a capacitor as a filter. The capacitor charges when the voltage increases and it discharges when it drops, which reduces the ripple in the current and provides a more constant DC voltage. So we can see that the graph is getting more flat. Next up is the Zener diode, which acts as a voltage regulator. It keeps the output voltage constant even if the input or load of the resistor changes. So, the Zener diode only conducts in reverse bias when the voltage exceeding the breakdown voltage of the Zener diode. So, if V input is larger than the breakdown voltage of the Zener diode, the diode clamps to the voltage of the Zener diode, protecting the load and stabilizing the output voltage. So now let's take a look at the Tinkercad simulation of the full wave rectifier power supply. As you can see, the AC input goes through the bridge rectifier, gets smoothened out by the capacitor and then regulated by the Zener diode to a constant DC voltage at the output. You will notice a resistor before the Zener diode. This resistor limits the current through the Zener. Without it, the diode might overheat and break. It drops the excess voltage and ensures the Zener only gets the current it needs for regulation. So we are using a resistor with the value of 5 kilo ohms. This was calculated based on the expected input voltage and Zener breakdown voltage. So let's take a look on the graph. Here's the graph of the output voltage we get from the Tinkercad simulation. First, before the rectifying of the waveform, the wave is having a positive and negative half cycle. Then after filtering through the capacitor, it smoothens out the direct current with minor ripples. Finally, after the Zener, it will be a stable and flat voltage. This is shown as a progression from an alternating current to a clean direct current. So let's take a look at the calculation quickly. So the V input given from the alternating current is 10 sinus 50t volt. So we take the Vp as 10 volt and then we can find the V root mean square as 7.07 volt. If it's an ideal circuit, means the diode has no voltage drop, the V peak will be 10 volt. If it's not an ideal, it will be V peak minus 2 diodes, which is 0.7 multiplied by 2, so we get 8.6. volt. So we can get the resistor load voltage drop as the voltage divider formula, and we get 4.3. So the Zener diode breakdown voltage is 2 volts, and as we can see, the resistor load is larger than the Zener breakdown voltage, so the Zener diode is on. That's all from our group, which is group 7, and thank you.